All right, the next thing we want to talk about is horizontal asymptotes, and so we're going to revisit this acronym that we learned back in Chapter 1 about how to find a horizontal asymptote. So Bobo Bottom eats DC, just as a reminder, this stands for bigger on bottom. And remember, when we say bigger on bottom, we're talking about the exponent, the degree of the numerator and the denominator. So if the denominator has the bigger degree, then y equals 0 is going to be your horizontal asymptote. If the degree of the numerator is bigger, or bigger on top, this means that there is going to be no horizontal asymptote. There is going to be the possibility, though, of a slant asymptote, and we're going to talk about that in Roman numeral 3 of these notes. And then finally, if the exponents are the same, so we can just say the degrees are equal, then what that means is that you're going to divide the coefficients in order to get the horizontal asymptote. So same degree, exponents are the same, divide the coefficients in order to get the horizontal asymptote. Okay, so real quick, just a reminder how to do this in case you forgot. In letter A, we see that in order to find the horizontal asymptote, we look at the biggest term in the numerator and denominator, and that would be 4x squared and 2x squared. And since those exponents or degrees are equal or the same, we're going to divide the coefficients in order to get our horizontal asymptote. And so 4 divided by 2 is going to give me a horizontal asymptote of y equals 2. In letter B, I've got a first degree polynomial in the numerator, a second degree polynomial in the denominator. So that means that the exponent is bigger on the bottom in the denominator. And so therefore that follows the Bobo case, which means that y equals to 0 is going to be your horizontal asymptote. In letter C, we see that we have a third degree polynomial in the numerator, or a cubic polynomial, and in the denominator we have a second degree polynomial. Therefore the degree is higher in the numerator, or on top, and so there is no horizontal asymptote. But this function in letter C is going to have what we call a slant asymptote, and the reason for that is that the degree in the numerator is exactly one more than the degree in the denominator. But I'm getting a little bit ahead of myself. That is coming up a little bit later on in the notes. Okay, and then letter D, hopefully you're catching on to this if you were not able to catch up on it in Chapter 1. And so here I see that the exponents are the same. Therefore, I'm going to divide the coefficients to get my horizontal asymptote y equals to 3/2.